Have you ever tried keeping a houseplant alive? They need the perfect amount of sunlight, water, and soil nutrients in order to thrive. I'm really bad at it, mine keep dying. So I can't imagine how much more challenging it's been for the team at the National Biologics Facility to keep 50 litres of cells alive and healthy enough to produce quality vaccine antigen. Luckily, the team has a wealth of experience in the area. Today, I'm joining the team as they continue the process of purifying their vaccine antigen, ready for dispensing and final quality checks. Welcome to Day Zero to Breakthrough. A few days before downstream processing, or purification, of the vaccine antigen began, I joined Greeshma and Justin from upstream processes to have a look at the bioreactor, which is where the team have been growing up a big batch of cells since day 138. Now, the bioreactor is chock full of our lead vaccine candidate Q. I watched as Justin and Greeshma performed daily monitoring of the big batch. They made sure the pH and CO2 levels were optimal for cell survival and checked the health of the cells by monitoring viability. They've been doing this every day since the batch began, making sure the cells are well fed, happy, and healthy. This ensures maximum, high-quality product is produced. The team harvested the bioreactor the next day, passing the supernatant through a series of filters to get rid of dead cells, unwanted proteins, and any viral contaminants. I joined Karen and the downstream processing team as they got ready for the next step in their filtration process. While we waited for the rest of the team to get into their bunny suits, Karen updated me on how the harvest went.
So this batch was actually very productive. They made, for the viral antigens we've been working with, they've expressed in a range, and this one is one of the higher expressors, so we got a lot more protein in the material than we were expecting.
Producing high yields is a great quality for our vaccine antigen to have. In a real pandemic, the more vaccine we can produce more rapidly, the more doses will be available for human clinical trials and eventually protecting our community. Karen also explained how the molecular clamp technology has helped them in the purification process so far.
So in chromatography, affinity chromatography is one of the most powerful purification tools because it's so selective for the protein that you're interested in, whereas a lot of other chromatography techniques like ion exchange or hydrophobic interactions, they grab groups of proteins, so you have to kind of add multiple chromatography steps together to get the degree of purification you need. Whereas with affinity chromatography, it looks specifically for that one thing. So they have a custom resin that's been built that looks specifically for the molecular clamp and pulls just that protein down. So you can get a very high degree of purification across just one step, which is just very powerful.
I've learnt that most of the work NBF does is paperwork. They are incredibly meticulous about keeping track of everything. The temperature the antigen is stored at, how much it weighs, the batch number of any reagents they're using, all in the name of quality. Today, they are performing something called a tangential flow filtration, or TFF, which has two purposes. One, it helps further purify the vaccine antigen. And two, it moves the antigen from a very salty liquid, which is used in the affinity chromatography step, to something more suitable for future processing. The downstream team are going to be busy with purification for the next few days. Next time we check in, I'll be joining them as they dispense the vaccine into vials, ready for final quality checks on Q before it goes off to a hypothetical clinical trial. See you next time. It's very nearly time for breakthrough.